Hello everyone, my name is Caitlin Duncan and today I'm going to be talking about symptom tracking app data and its potential uses for explainable artificial intelligence. I am a postdoc at Osaka University and I'm working on this project with Professor Takayuki Nagai. Before I actually start discussing this work, I wanted to briefly talk about my motivation for presenting at this specific workshop. We currently have several ideas for ways this data could be used, and I wanted to talk about some of these in order to really just start a discussion around this topic. I expect this workshop is being attended by experts in the field and people who are passionate about healthcare and AI, so I wanted to share this idea here. This is partially to draw attention to this type of data and the possibilities it offers in helping people with chronic illnesses. And also because I'm hoping to hear other people's opinions or potential insights into how this data could be used. And I'd love to discuss this with anyone who is interested in it or is potentially working on something similar. Right, now on to the rest of the talk. The core motivation behind this work is to find ways to assist people with chronic illnesses in managing their health. Chronic illness is estimated to affect over 1/3 of adults worldwide, and with the emergence of long COVID, this is likely to increase in the next few years. Many people with these illnesses take a particularly active role in their healthcare, and self-tracking is one of the common ways that people do this. By self-tracking, I mean recording details about one's own health. For example, the medications they're taking or the symptoms they're currently experiencing. Now, as a healthcare tool, self-tracking is nothing new. Practices like keeping migraine diaries or monitoring food intake or body temperature have obviously been around for a very long time. And the oldest form of health tracking practices are most likely menstrual calendars and records, and these have been around for thousands of years. What is new in this area, however, is how we can track information about our own health. This is because advances in technology have given us many different ways of gathering and recording data. This transition to collecting predominantly digital data opens up many possibilities for applying more advanced data analysis techniques, along with machine learning and potentially XAI. Digital tools for self-tracking can be divided into two broad categories based on how they collect the data. Passive tracking is generally used to refer to tools like wearable devices or body sensors, as these collect data automatically without a user having to directly input the information. Symptom tracking apps, on the other hand, fall into the category of active tracking, as these require direct input from a user. So each time data is recorded, a user has to actively carry out this task. Now, both of these types of data are highly valuable, but they have very different characteristics. And at this point in time for this project, we are focusing purely on active tracking data from apps. There are a wide variety of these symptom and health tracking apps available. These are two of my particular favorites. Some of these apps are specific to certain conditions, for example, Migraine Buddy, which is used for tracking migraines. Others, such as Bearable, are more generalized and can be used to track a wide variety of factors and could be applicable to a wide variety of illnesses. Now, we know these apps are popular, particularly among those with chronic illnesses, but it isn't entirely clear at this point how beneficial using these actually is for the users and how much it impacts their overall health. In the research we reviewed on this topic, we found reports that simply recording different factors like symptoms and medications can help people notice patterns between these, and it can have a positive impact on their health. However, this didn't seem to happen for the majority of users in these studies. So recording the data can be helpful, but it doesn't seem to have a large effect. As a way of assisting users, many of these apps include data visualizations and in some cases present statistics and information about correlations between factors. While this can be very useful, interpreting this type of information requires a certain degree of data literacy and effort on the user's part. It's likely that there are many useful pieces of information for a user in the data they have collected, and we want to investigate ways of building personalized models for users from this data. These could then ideally be used to do things like identify triggers and patterns in their illnesses, maybe examine the impact of different treatments, or provide explanations of past health events, such as depressive episodes or flare-ups of symptoms, and also to generally predict future symptom severity. Now, as you may have guessed, this is easier said than done with this particular type of data. And I'll get into some of the specific reasons why that is later in this talk. So where does explainable artificial intelligence come into all of this? Firstly, identifying how a user model has been constructed or how it makes decisions could be a good method of extracting information about things like symptom triggers or the effect of different treatments. This is the original idea behind this project. We thought that if we can apply explainable AI and identify the core factors contributing to how a model is functioning, then we could use this information to generate explanations for users. Secondly, presenting information like this to users has the potential to have a very strong impact on their health and behaviors. This would ideally be a positive one, and a positive one is the goal of this. But if it isn't, then presenting this information could be a dangerous thing to do. Because of this, it would also be crucial to validate the way the model is making decisions before presenting any explanations to users. The consequences of the model making poor decisions could be immense for users. And if we don't know how it's working, it would be very irresponsible to use it. So that is the background on this project. And now I'm going to move on to our preliminary work on this. The first step in this project was to investigate the general nature of this type of data. And luckily, there is a large open source data set from one of these symptom tracking apps available. It's available through the dataset sharing website Kaggle. This app is called Flare Down and is targeted at people with chronic illnesses. A quick description of this app and the data it collects. It functions by letting users check in each day and log their symptoms, conditions, treatments, and food. And it also has a generic tag category. Users can also choose to have the app automatically collect data on weather as well. One of the core features of the app, and similar ones to this, is it lets users customize exactly what they are tracking. To explain this, here is an example of the data that might be collected on a specific user. Each of the items that a user chooses to track are referred to in this data set as trackables. So for example, this user entered the trackable fibromyalgia as one of their conditions, and the trackable ibuprofen as one of the treatments they use. So each day a user will put in an entry for each of these trackables. For conditions and symptoms, they will put in a value indicating the severity of that day. For treatments, they will put in the quantity of that, or in some cases, this isn't a medication, and they will put in an additional note on this instead. Then for tags and food, the value is simply 1 to indicate that it happened that day. So this is the type of data that would be collected on a user. So some general information on this data set. It contains information from over 42,000 people who between them put in almost 8 million individual entries. There are a lot of different things that people have tracked within this. There are over 111,000 different trackables that have been used. This data set is a little bit biased because over 50% of the users are based in the US, and almost all entries are put in English. I think there's about less than 100 that aren't in English. Now, the number of users in this data set seems pretty big until we examine how long most users used the app for. Prepare yourself for a lot of histograms in this next section. So 45% of users in this data set only made one entry, and only about 10% of these people used the app for 20 days or more. So this is a pretty massive skew in the data set. To check that this actually was the case, we manually inspected a random selection of users with the same demographics and who entered data around the same time frame to make sure there weren't entries that had been split somehow. We didn't find any indication that particular users had been split among different user IDs. On an individual user level, this lack of entries isn't really an issue. If someone only used the app for a week, they probably won't mind never getting more information from it, whereas someone who used it for a long time is the target of this work. However, this does greatly decrease the amount of data we have available to use for training or analysis. Since all of this data is time series data, its temporal nature is crucial. And if someone only entered data over 3 days, then that's not going to be useful for training. So because of this discrepancy in how long people use the app for, from this point onwards, I'll be talking only about the users who entered data on at least 20 occasions. So some quick population characteristics. Over 80% of these users reported their sex as female. Only 80% reported it as male, 4% as other, and 8% didn't enter a sex. This skew towards female users is likely influenced by the fact that many chronic illnesses disproportionately affect females, and the app was also used by some for menstrual tracking. There was quite a large age distribution in the app, ranging from 1-year-olds to 99-year-olds. The average age was 35, with most people around the 20 to 45 years age group. These distributions were pretty consistent when we included all users, not just the users who put in data for 20 days or more. So now into the more insightful data, the trackables that people used. There was a really large range in the number of trackables that users entered in each category. Some people only tracked a couple of conditions and treatments, whereas others were tracking over 100 different symptoms alone. And the range of different ways people use the app is really massive. Inspecting these entries was really fascinating because there is just so much variation in terms of how people want to record their health. This is really interesting, but pretty much all the difficulties with using this data stem from the flexibility that the app provides users with. This is always going to be a problem though, because having this flexibility is one of the core features that make these apps useful. One way we could make this data more usable in the future is to use apps that have a very defined set of factors that people can track. But this really defeats the purpose of these apps because it controls what the user can track when they actually want flexibility in that. Here are some examples to illustrate these particular challenges. There are many cases in this data set where 2 users are essentially tracking the exact same thing, but their name for that trackable is different. For example, one of the most commonly logged symptoms was headache. However, this was entered in many different ways. Some users misspelt it or wrote headaches or chronic headaches. Some had multiple ways of logging the headache related to its cause, time, or bodily location of it. For example, sinus headache or evening headache. Some of these are easy to deal with, such as misspellings and plurals, but whether or not other trackables like sinus headache and chronic headache should be considered the same thing is a bit more complicated and potentially entirely user dependent. An interesting thing we came across as well was the use of highly personalized trackables that probably mean a lot to the user, but are a bit difficult to interpret. For example, particular emojis being used, or the word "where lobster," which we came across. There were also many colloquialisms in the data. For those of you who are familiar with the spoon theory metaphor, this was quite a common trackable used. The variation between trackables in the condition category was for many of the same reasons as for symptoms. There was a lot of variation in the specificity of the conditions and colloquialisms used. And also commonly acronyms introduced issues. Some of these were very common and specific. However, some could have multiple meanings. Now, when we look at the top conditions and symptoms, we also find quite a lot of overlap related to how an individual user interprets the words condition and symptom. It's also interesting to note here that sometimes items with the exact same name might be being used to refer to different things and might not be considered the same thing. For example, depression could be being used to refer to a major depressive disorder, but another person might be using that same trackable just to refer to their mood on that particular day. It's really personal to a user, so whether or not these can both be used when training a model in the same way is difficult to establish. Now, I'm bringing up a lot of challenges with this data, but the thing is these challenges also stem from the qualities that make this data so informative and potentially useful. The highly personal nature of the information is both a positive and a negative, and it's something that we want to use rather than get rid of, if that's possible. Again, similar discrepancies come up with treatments. Some of these are easy to deal with, particularly when specific medications are logged, because the main way these vary is brand names or in specific dosages, and this can be standardized. But others are, once again, so individualized or don't have a dosage associated with them. And so we can't really treat these in the same way when they're analyzed. In regards to tags and food, the same issues come up again, but also these categories can be even more user specific. For example, some people take notes using tags, and for those people who do log the same type of food multiple times, this data could be very useful when we compare it to people who log things so specifically that the same type of food doesn't turn up more than once. So where to from here? Like I said at the beginning of this talk, I really wanted to present this to start a discussion about this type of data. Some of the directions we're looking at going in are looking at methods for standardizing the data rather than diving straight into creating the models. When it comes to creating the models, though, we are looking at logging short-term memory models or potentially making use of pre-trained NLP models, since the temporal nature of this data is so critical. We're also wondering about integrating health databases or making use of these to decrease training requirements, because then we can associate symptoms and conditions together before we analyze any data. Another possible direction is to step back and look at clustering across all users rather than individuals. So now is the time in the presentation when we all ask for questions. But along with questions, I'd love to hear anyone's insights or opinions on this project or the potential of applying explainable AI and machine learning to this type of data. Thank you.